Alright guys, it's Toa Tech back again, and today we're going to do another tutorial on the Godot engine. So, hope everyone had a good holiday. It's 2017. So yeah, let's just get into it. So, what we're going to do right now is add in a character to our little world. Because right now all we have, if I click play real quick, is this background. So under World 2D, we're going to add a Kinematics 2D. So if you just type in kinematics there, kinematics by 2D, and create. So this is a character we have that we're going to create now. So let's just talk a little bit about what a kinematic body is. So kinematics is something to do with physics. Kinematics is the physics of movement, more or less. And by having a kinematics body 2D thing in our scene here, we're essentially saying to the engine, okay, you have a bunch of physics stuff pre-coded for us, because that's a lot of math that I would enjoy digging into, but it's also very complex. So this engine does it for us. And it's basically taking in other code written by the developers to actually create this kinematic work for us. So this stuff gets affected by gravity and movement and all that kind of stuff. So with the kinematics body selected, we also want to add another node for an image. And for some reason it's escaping on my sprite, so we need a sprite, that's what it's called. So let's just add in a sprite. And I actually have a character created. It is very high definition artwork, as you can see. Alright, so when we play it now, you can see that it's not being affected by gravity or anything. And the reason why is because we actually haven't told the game that there is gravity. And essentially what that means is the game doesn't know if this is a top-down view, in which case gravity is going towards the screen, if there is gravity. Sometimes there isn't. Or if this is indeed the way we see it, where gravity is down, etc. So what we need to do is actually add in that ourselves. So selecting the kinematics body 2D, we're going to right click and add a script. Now I actually have a script pre-made, player.gd, and what we're going to do is actually load that in. There we go. So this now has something attached to it, and as you can see, gravity works. Now the reason I have a script pre-made is because I tried making this video a while ago and ran into a lot of issues. Reason being is because the last time I used Godot, which was months ago, they had things slightly different. So I looked onto the documentation, found a few things, and have a script pre-made. But what I will do is go over the script. Now, the way the script works is I'm just going to read it out to you guys basically top to bottom and explain each line as we go. So the first line, extends kinematic body 2D. For those of you who don't code, this is probably helpful. If you do code, you can probably skip over this little section here real quick. So extending the kinematic body 2D is basically saying it has another class full of this physics information that the kinematic body has, and it's extending upon that. It's taking all that code, essentially copy and pasting it in, and you're adding on to it with your own code. So that's all that's doing. Next we have two constants, which you define by the word const. So we have one constant called gravity and one called walk speed. And just a quick side note, typically in programming, constants are all capital letters. This way we know that it's a constant because every letter is a capital, and it's just a thing that people do. So we have a constant called gravity, which has a strength of 200, or a value of 200. And what that's essentially saying is just that it's a random value assigned to it that we kind of just guessed with. I may have just copied and pasted this off the website, but I can at least explain it. And we also have a constant called walk speed, which is 200. And that's just a value saying how many units of measurement it moves. And then you can define how much time it takes. Typically it's in per second or per frame or something, typically. Next we have a variable called velocity. Now this is different from the constants up above because it's defined with var. So both are types of variables. A constant variable never changes, whereas something var, velocity for example, does change. And the reason why is because it varies, hence var, missing a y for vary, you can think of it that way. And it varies depending on what is happening. So it can take in constants in order to redirect its output, but it's essentially like a mathematical function, y equals mx plus b, where y is going to be your output depending on what you input to this math equation, which is essentially what this is doing. Velocity will be your output of whatever you throw into this vector 2. And vector 2 is just it's a built-in function to Godot, very important for 2D games. It's a vector is just a two-dimensional line, you can think of it as. That's the simplest way to think of it. Telling something that you can basically say it's going up and left, for example, or something like that. It makes more sense to actually see it in action than it does to explain it. But essentially it's just going to take in an x and a y position, and that will be your vector. That point or a line, a vector. Next we have a function called fixed process. Now this is a built-in process built into Godot as well that you would need in order to actually start any coding such as the one you see in front of you. And the reason why is because it's an interesting way it has a code. I've never actually done it this way personally when I've programmed. But in Godot, there's something called fixed process in order to make sure that the engine knows where to start reading the code. So this function known as fixed process takes in a argument called delta. And delta is, again, that's another physics thing I remember from physics class last year, where it's a change in something. So, for example, if you have delta speed, that's a change in speed. When delta is typically, if you see it in math, it's typically in a triangle, and then there's a variable after it saying delta, and then whatever your variable is. And this just takes in that as an argument to make sure that when you do call this function, it has this delta ready to go. So next we have velocity.y plus equals delta multiplied by gravity. Very confusing if you've never programmed. If you programmed before, this is probably child's play. What it's essentially saying is you have a variable called velocity, the one that we described earlier, which is the vector 2. And you're going to look at its y component. Now y in Cartesian coordinates is up and down. So you're looking at the y coordinate and saying that it's going to move on its y-axis, and then you're describing by how much. Now, plus equals, it might look a little strange, is actually a shorthand version of saying velocity.y equals velocity.y plus delta multiplied by gravity. If you say plus equals, basically the compiler or the computer itself knows, oh, you're basically saying this but in a shorthand version. So it saves you a little bit of time. So we're saying now that the y velocity is the delta, which is whatever it could be at the moment. It's a variable, it changes multiple times, multiplied by your gravity. So it's delta, whatever that is, multiplied by 200. Now, you might think that you might actually need a negative value because on the y-axis, you're moving down according to gravity. But in computer terms, down is actually a positive y. So up here in the corner where you see this little Godot icon, probably is hard to see, but up by the scene here, is 0, 0 in the coordinate plane. And as we move to the right, you're increasing your x. Now, as we move down, we're increasing the y. Mainly because it wouldn't make sense to increase the y as you go down, or sorry, decrease it, because you can't really have a negative resolution. It doesn't quite make sense. So next, we have this little if statement. And if statements are just ways to check if something is true or not. So if input.isAction pressed, that is basically saying if you have an input that is being triggered or pressed in this case, and then you have what the action name is, move left. Now I'm not quite sure if I went over this earlier, but move left is actually something that we create ourselves. So just go under scene, project settings, and I just lost it. And if we go under the input map, and we scroll down, I just created something here called move left. If you want to do that, you just type in an action, click add, and then in order to make the keys work, you just click the little plus button beside the name. So as you can see, move left has A and a left. And this way we can code the game very easily for the movements, and we can have, for example, A and the left key move left without coding that in as two different actions. So it's going to see, back to the code, it's going to see if we moved left by pressing either A or the left key. And if that is true, we're going to look at the X velocity or the X movement and say that it's equal to the negative walk speed, and negative walk speed being negative 200, because we're just taking the negative of walk speed, which again mathematically makes sense, as if we move negative on the X, we're moving to the left. And then it's also going to check if we click the move right, which is going to be either D or the right key, in which case it's going to take the X velocity and move it to the right, or in a positive manner, which makes sense. Now, if none of the other conditions are true, and by the way, elif is just saying else if. It's another way of saying if this happens, okay, check the next thing, if this happens. And it's what you do if you have multiple ifs to try out for different actions. So if this is true, elif right, and then maybe elif down, elif up, etc. And then it's going to see if nothing else is true, if you haven't moved right, if you haven't moved left, it's going to set your velocity on your x-axis to 0, in which case you just sit there. So hopefully that makes sense. Hopefully I'm not moving too fast. Hopefully I'm not murmuring too much. If I am, just leave something in the comments. I'll be happy to explain. Anyway, next thing we have is motion. So again, it's a variable. It can change. And motion is equal to velocity multiplied by our delta. So our velocity being walk speed or negative walk speed. Also, we have a y velocity. So it's combining those together for us in a vector, you could say. And this is where the vector comes in. It's taking the x and the y component of each piece, which is this here and this here. And it's multiplying that by our delta. Delta being the change in, or the time, you could say. And that's all it's doing. It's just making our character actually move. And then the next line is move motion. So move is a function, and you can tell it's a function because it has parentheses. And it's going to take in an argument, and the argument being motion, which is the variable we created just above. So it's going to move, which is a built-in function to Godot, and it's going to move by the exact amount that is described by motion, which is our velocity and delta. So that's it for that entire function. That one function basically moves our character. Now, this function doesn't actually work until we call it in our ready function. And the ready function is built in every time you create a new script. You have this ready function. It's the first thing that the computer or the engine reads, essentially, when it's ready to run your code. So it's going to look at the ready function and say, okay, what am I doing here? Set fixed process true. Okay, I'll do that. And what is fixed process? It is this up here. So again, built-in function. And you're just setting it to be true because you want it to actually work. Sometimes you want it to be false. For example, if you have an in-game cutscene and you don't want your character moving around or your player to be doing all this stuff, you can set it to be false, and then you won't have access to moving. And then after your cutscene's over, you can set it to true again in order to actually move around. So that's kind of how that works. And after all that, if we click play, we can move around. Now, you might notice an issue, and that is that we fall down through the ground. So, in order to fix that, we must actually create an obstacle. So what we're going to do is select the world 2D and create a static body. And what a static body does is it doesn't really move or anything. It just kind of interacts with other things. And we're just going to move it down here and resize it. And we're also going to add a sprite to it so we can actually see that we're interacting with something. And again, I already have a pre-made texture. It's not pretty, but it works. It's a very large texture. So I'm just going to create that and put it back to its original scale of 1:1. And let's actually shrink this sprite down to about a quarter of its original size, just to get this properly lined up. Yeah, its position should be its original. This is where the fun comes into this. It's essentially trying to get everything to fit. Now, this is one thing I actually did not enjoy about Godot for quite a while, is trying to get things to, like this, to work, essentially. And we're just going to make it a little bit bigger than the actual bounding area around here. And that's okay, because this is the actual physics piece right here. Now, by itself, if we click play, it won't do much. As you can see, our character falls right through. Actually, falls behind. And in order to make sure it's in front, just make sure it's the last thing on the list. And then if we click play, you can see he just kind of falls right through. Reason being is that there's actually no collision body to tell it when to stop. So what we want to do is select either one first. Let's just go with the static body here. And we want to add in, under the physics, or sorry, collision objects, area 2D, right under the physics body 2D area there. And area 2D is just a node to tell us what the collision area will be. So if we do that to each, I believe this is where I actually got stuck last time. So hopefully it doesn't happen again. And you can see that when it happens, it goes right through. So this is something that happened last time, and I'm not entirely sure why. It might just be a bug, because it seems to work normally. But to figure that out, I just need to pause the video real quick. Alright, so I kind of messed up again. This is the same mistake I made last time, which is a little embarrassing. So we have to do, instead of an area 2D node, which just tells us the area, collision shape 2D. That's embarrassing. So what we do is we select that and select the shape sorry, to be a rectangle shape. Sorry about that. And then we can resize the shape here or just down here. So you can see maybe a 5x5, maybe a little higher on the Y actually, and 5x7. Something like that. And then select the little character guy, and also alright, and same exact thing, rectangle shape with the scaling maybe 4x4. Perfect. Saving that and running it will actually lead to this happening. So we finally have it to work, and he lands on the ground, with the issue being that if we do press any of the keys, he doesn't actually move, and when he does, it's barely by a pixel even. So that is that, and I'm actually going to have a challenge for this video. I want to see who can actually figure out why that is. Why is it that the little character cannot move once he hits the ground? So yeah, that's the way for you guys to learn more about Godot and how to implement things when you get stuck. So I do know the solution to this, and hopefully I'll put up another video within the next week or two, I think, depending on how busy I am at work. But yeah, hopefully you guys understood a few things I said there, can start working out a game project of your own. Thank you for watching, and I'll see you guys next time. Peace.